Hello guys, thank you and welcome back to my YouTube channel. In this tutorial, I'm going to teach about the vectors question that I was sent with one of my students. I'm going to talk about this question, which is in the chapter of vectors, that is Form 3 work. Now the question reads: the figure below shows a triangle OAB. In OAB, in which OA is equal to A and OB is equal to B. M and N are points on OB and AB respectively, such that OM is equal to a third OB and 5AN is equal to 2AB. Lines AM and ON meet at P. So in this one we have the triangle that we have been told, OAB. So triangle OAB is this one. So that OP is equal to 5 over 9 ON. So this is the triangle OAB. So this is OB. Then we got ON and OA. So now the question tells us that OA is small a. So these are small a. OB is a small b. M and N are points on OB and AB. So M is the point that is lying along OB, and N is a point that is lying along AB. AB, this line AB. Such that OM is a third OB. So OM is equal to a third OB, and 5AN is equal to 2AB. Lines AM and ON meet at P, such that OP is equal to 5 over 9 ON. So this is OP, then ON. Express the following vectors in terms of A and B. Then we go to vector AB, then we have vector ON, AM, and part B of the question reads: express AP and PM in terms of A and B, and hence show that the points A, P, and M are collinear. That is 5 marks. Then state the ratio AP to PM. This question is very easy. It is very easy to solve. You don't need to struggle. You only need to know the direction that you are taking to get a given vectors in terms of A and B. So let me start with part A. Express the following vectors in terms of A and B. That is Roman 1 of part A. Vector AB. So OA, that is the direction OA. So you need to find AB. So AB, this direction now. So now to move from A to B, we can start from point A, that is the starting point, then we finish at B. So from A to B, this is the same as AO plus OB. So this is equal to, so AB is equal to AO plus OB. So you need to follow that direction for us to reach point AB. So now AO, we don't have AO, but we have OA. Now OA is small a. Now AO now is in negative direction now. So it becomes negative OA. So this is the same as minus OA plus OB. We got OB. So minus OA. So the negative of OA is minus A plus OB is given by vector B. So the answer here is B minus A. So that is AB in terms of A and B. Now, part A, Roman 2 of the question, now vector ON in terms of A and B. ON. We now need to move from O to N, this direction now. We are going to use the given vectors, that is vector A. So we are going to move, when we want to move from O to N, we want to follow this direction from O to N. We can move from OA, then from A to N. So ON is equivalent to OA plus AN. Show the direction. Now vector OA, we already have it to be A. So this is the same as A plus AN. We don't have AN, but there's a relationship between AB and AN. Now, we were told that 5AN is equal to 2AB. So when you divide both sides by 5, this implies that AN is equal to 2 over 5 AB. So in this case, our AN is the same as 2 over 5 of the total length AB. So this is the same as 2 over 5 of AB. So that is length AN. Now that becomes, the equation now becomes A plus 2 over 5. But our AB from the first part was B minus A. So this is 2 over 5 to bracket B minus A. So when you open the bracket by multiplying what is outside by the outside the bracket by what is inside by in the bracket, so this ON is equivalent to A plus 2 over 3 B minus 2 over 5 A. Now, because we are having handwritten, we must put this bouncing line to show that it's a vector. So the ON is equal to A, that is collection of the like terms, minus 2 over 3A, 2 over 5A, plus, this is 2 over 5, 2 over 5B. So that is ON. Now we are collecting the like terms to find the final value. So ON is equal to A minus 2 over 5, that is 3 over 5A, plus 2 over 5B. So that is vector ON in terms of A and B. Now again, vector AM in terms of A and B. We want to move from A to M. So for us to reach AM, for us to move from point A to M, we can move from A to O, then from O to M. That one gives us the vector AM. So this is the same as AM is equal to AO plus OM. So AO was the negative of OA. So this is negative A plus OM. Our OM is equal to a third OB. And our OB is B. So this is a third B. So this is the same as a third B minus A. So now part B, express AP and M, AP and PM in terms of A and B and show that AP and M are collinear. So I want to start the first part to express AP in terms of A and B. Now for us to move from point A to P, we can take the part AO plus OP. So AP is equal to AO plus OP. So AO, our AO here was negative A. So this is minus A plus OP. Our OP here is 5 over 9 OM. 5 over 9 OM. So this is equal to minus A plus 5 over 9. We had already find OM, 3 over 5A plus 2 over 5B. 3 over 5A plus 2 over 5B. Minus 2 over 3A plus 2 over 9B. So this is AP in terms of A and B. AP in terms of A and B is minus 2 over 3A plus 2 over 9B. Now the second part, now PM, direction PM. PM in terms of A and B, we can move PO plus OM. Now PO is the negative of OP. So this is the same as minus OP. OP minus OP plus OM. Because we want to move from P to O. P to O, that is the negative of OP. And OP was 5 over 9 ON. So it will be minus of into bracket a third A plus 2 over 3, 2 over 9 B plus OM. But now our OM was a third OB. A third OB, which is B. So now we are expressing PM in third A minus 2 over 9 B plus a third B minus a third A plus 1 over 9 B. So this is PM in terms of A and B. Now we got AP in terms of A and B and PM in terms of A and B. Now we want to show that points AP and M are collinear. Now how do we show that AP and M are collinear? Now to test for collinearity, there are two things that are involved. One must be a scalar multiple of another one, and there must exist a common point. Now we got vector AP and vector PM. Now P being a common point, that is the first sign that these 2 points, these two vectors might be collinear to one another. So P being common points on both AP and PM, P is a common point now. We want to see whether AP and PM, one is a scalar multiple of another one. So the first condition for collinearity is there must exist a common point, which is P. Then the second condition is that one must be a scalar multiple of another. One vector should be a scalar multiple of another. Now in this case, when you have AP is 2 over 3, then this one is a third, negative 2 over 3, and this is negative a third. So, and also 2 over 9b and 1 over 9b. What does it mean? This vector AP is equal to twice vector PM. Because when you take vector PM, you multiply by 2. This vector PM multiply by 2. So 2 times negative a third, you get negative 2 over 3A plus 1 over 9B times 2, we get 2 over 9. So vector AP is equal to 2 PM. Hence, these 2 points are collinear. P is a common point. P is common point. Hence, collinear. Now to go to the last part of the question, ratio AP to PM. So AP is equivalent to 2 PM. So this PM cancel this one. So now we got AP over PM. Ratio AP over ratio PM. We are dividing because we want to see what is that ratio. What is that ratio? So AP is 2 over PM, which we are left with 1. So the answer is 2 to 1. And that is how you score your 10 marks. Thank you. Subscribe for more updates and